Dear students, in this video, we will discuss about metal carbonyls and their classification. I am Dr. R. Jalababu, lecturer in chemistry, SCIM Government Degree College, Tanuku. In this video, learning objectives are definition of metal carbonyls, the general characteristic properties of metal carbonyls, structure of carbon monoxide, bonding in metal carbonyls, and finally classification of metal carbonyls. What are the metal carbonyl compounds? When the transition metal atoms coordinate with carbon atom of carbon monoxide ligand leads to formation of metal carbonyl complexes are known as metal carbonyls. Here metal carbonyls are the complex compounds. So here the complex between metal and the CO ligand. So here the CO ligand, it contains the lone pair. It donates to vacant orbital of this metal atom. So the formation of complex compounds. So the coordinate covalent bond is formed between metal and carbon atom of the carbonyl ligand. It is represented by MCO. So the arrow towards metal from CO ligand. So here that means the CO ligand donates electron pair from here to vacant metal atom. So the metal carbonyls are the complex compounds between the transition metal and CO ligand. The general characteristic properties of metal carbonyls. The metal carbonyls oxidation state, it is the 0 for metal atoms. Actually, the metal carbonyls, the CO ligand, it is the neutral ligand. That's why metal carbonyls, the metal exhibit 0 oxidation state. But in some metal carbonyl complexes, metal exhibit positive or negative oxidation states also. For example, if you take sodium, vanadium, CO6 complex. Here, the sodium metal with positive oxidation state and complex negative. So the vanadium, it is the -1 oxidation state because CO is the neutral ligand. So the metal carbonyl complex vanadium exhibit the -1 oxidation state. And another carbonyl compound, that is the manganese CO, that is the manganese CO6 Cl. Here the chloride is negative oxidation state and complex is positive oxidation state. CO is the neutral ligand. So manganese exhibit positive, that is the +1 oxidation state. Generally, that is the metals exhibit the 0 oxidation state but some complexes also, that is the negative one, positive oxidation states. Except vanadium carbonyl VCO6, the remaining metal carbonyls are the diamagnetic nature. So these metal carbonyls, in the presence of this strong field ligand CO, all the electrons are paid. There is the no unpaid electron. No unpaid electron. So there is the no unpaired electron in these complexes. So these are the diamagnetic nature. But here vanadium CO6 complex, the vanadium metal with one ox, that is the one unpaired electron, one electron. So the presence of this one unpaired electron, the vanadium complex exhibit the paramagnetic nature, and the remaining complexes are the diamagnetic. The next one, the metal carbonyl compounds easily decompose into metal and CO on heating. For example, if you take the nickel tetracarbonyl, metal carbonyl, so on heating, it is decomposed into nickel plus 4 CO ligands. So the complex on heating, the decompose into metal and the carbonyl ligands. The metal carbonyl compounds contain both sigma and pi bonds. So these carbonyl complex in between the metal and CO, so they are the donation of electron pair from CO ligand to metal to form the sigma bond, and by the back bonding, the metal lone pair or metal electron pair donates to carbon vacant orbital and form the pi bonds. So the metal carbonyls, both sigma and pi bonds are the possible in these compounds. The metal carbonyls are soluble in organic solvents. So generally, these carbonyls is the soluble in the organic solvents like benzene, carbon tetrachloride, chloroform, like the organic solvents, but insoluble in water. And these metal carbonyls, the CO ligand acts as a neutral ligand. Neutral ligands means this ligand, the CO, it contains the lone pair on the carbon atom, so it acts as a ligand, but the molecule is the total neutral molecule. There is the no charge on CO molecule like H2O and NH3. So these are also ligands, neutral ligands. Similarly, the CO is the acts as a neutral ligand in metal carbonyls. So in these metal carbonyls, the ligand is the CO molecule. So first of all, we know the structure of CO molecule. So in the CO molecule, the carbon atom atomic number is the 6 and electronic configuration 1s2, 2s2, 2p2. Here, that is the 1s2, this is the inner shell, and the 2s2, 2p2, this is the valency shell. So in this, the 2s2 and 2p2, 2px1 and 2py1 and 2pz is the vacant. So in this carbon, in the valency shell, there are the 4 electrons, 2s2, 2p2. So in this CO molecule, the carbon, it undergoes sp hybridization. So one s orbital and one p orbital undergo hybridization. So this is the sp hybridization, and the remaining two p orbitals are unhybridized with this one electron and this here vacant orbital. So the carbon atom undergo sp hybridization. And another atom, oxygen, with atomic number 8 and electronic configuration 1s2, 2s2, 2p4. Here, the valency shell electronic configuration. So there is the 2s2 and 2p4, 2px1, 2py1 and 2pz2. Here, there are the 6 electrons in this valency shell. Here also, the oxygen undergoes sp hybridization. That means one s orbital and one p orbitals undergo hybridization, and the remaining two p orbitals are not participates in the hybridization. So the both carbon and oxygen atoms undergo sp hybridization. So here the carbon atom, the sp hybridization. So the two sp hybrid orbitals are oriented in linear fashion. So with one unpaired electron and one lone pair. And this oxygen atom undergo sp hybridization. The sp orbitals, they are oriented in linear fashion, and they are the pypz. Both are p orbitals. They are the unhybridized p orbitals. These orbitals are oriented in the perpendicular to plane of the sp hybrid orbital axis. Now the carbon atom, one sp hybrid orbital with one electron, and this sp hybrid orbital with a single electron. These orbitals are the directly overlapping the formation of the sigma bond. So the sp hybrid orbitals are directly overlapping to form the sigma bond. And here the py orbital and oxygen py orbital, these unhybridized orbitals, they are overlapping by side wave overlapping the formation of this pi bond. So these one sigma bond and one pi bond is formed by this the oxygen and the carbon orbitals. And next the carbon, the contains the pz orbital, the vacant pz orbitals, and oxygen pz orbital with lone pair of electrons. Now the oxygen pz orbital electrons are donated to this pz orbital, vacant pz orbital of the carbon, the formation of the another pi bond. So the another pi bond, the second pi bond is formed between the carbon and the oxygen. So totally there are the three bonds between the carbon and oxygen. So the one, this is the one is the sigma bond and two are the pi bonds, total three bonds. And the carbon, one lone pair, and oxygen is also one lone pair. So this is the structure of the CO molecule. Next, we know about the bonding in metal carbonyls. So how the bonds are formed between the metal and the CO ligand. So here the CO, the carbon contains the lone pair, and the lone pair of electrons donated to these metal vacant d orbitals. So the formation of the sigma bond between the metal and the carbon atom. So this is the bond between the metal and the CO ligand. That is the formation of the sigma bond between the CO ligand and the metal. There is the another possibility of the bonding between the metal and the carbon. So here, so actually this is the sigma bond between this carbon and the metal. and this the uh, the vacant orbital of this carbon atom. Now there is the only two bonds between the carbon and oxygen. One is the sigma bond and another is the pi bond. Only two bonds. So there is the no donation of the electron pair of oxygen atom to the carbon. Here the carbon with this vacant orbital and oxygen with this lone pair. Now the metal electrons, that is the lone pair of electrons from the metal to, that is the vacant carbon atom orbitals. So this is the back bond, that is the reverse of the donation. Actually the donation of the electrons from the carbon to metal, but here in the back bond the electron pair donation from the metal to carbon and the formation of the another pi bond. So in this situation, the two bonds between this metal and the carbon, so one is the one sigma bond and this pi bond. In this situation, the carbon and oxygen, there are the two bonds, and here the one lone pair. This is the extra lone. So there are the two lone pairs for this oxygen atom, and there are these two bonds between the metal and the carbon. So the metal to CO pi bond formation, that is the back bond formation. Here actually two types of the bonds are possible between these metal and the CO ligand. So one is the metal, and there is the another. So here metal to carbon, there is the only one bond, there are the three bonds with the oxygen, and the back bonding is there, the metal carbon two bonds and carbon oxygen two bonds. So these two structures, they undergo the resonance. So they are the two types of these bonds are possible in the metal carbonyls. So this is the bonding in metal carbonyl compounds. So the next one is classification of metal carbonyls. Metal carbonyls are mainly classified into two types: mononuclear metal carbonyls and polynuclear metal carbonyls. Polynuclear metal carbonyls again divided into two types: the metal carbonyls without CO bridges, and the another one, the metal carbonyls with CO bridges. So we will detail explanation about this classification. So first one, mononuclear metal carbonyls. The mononuclear metal carbonyls means here the mono means that is the single one, and nuclear metal carbonyls. So in this carbonyls only one metal atom is present, that is the one nucleus is present in this metal carbonyls. So this general formula, that is the MCOX, and M for the metal atom, and X is the number of CO ligands. Here only one metal atom is present, and there are the X number of the CO ligands attached to the metal atom. So example, NiCO4 and FeCO5 and vanadium CO6 and the chromium CO6. So here the structure of the NiCO4, and here the nickel, one nickel metal atom is bonded to the four CO ligands tetrahedral manner, and the structure of the FeCO5. So here the iron metal is bonded to 5 CO ligands in trigonal bipyramidal structure, and the remaining structures of this chromium CO6 hexacarbonyl chromium. So here the structure is the octahedral, and similarly vanadium carbonyl complex VCO6, here also that is the octahedral structure. So the next one is polynuclear metal carbonyls. Polynuclear metal carbonyls means, poly means here two or more metal atoms are present in metal carbonyls. So the general formula of metal carbonyls MxCO5. So M for metal atom and X is the number of the metal atoms. So the X value here, what is the X value here? X is the R greater than or equals to 2. 2 or more than 2 metal atoms. And then Y is the number of the CO ligands. So this is the general formula for the polynuclear metal carbonyls. So these polynuclear metal carbonyls, again two types. They are the without CO bridges. So based on the CO ligands attachment without CO bridges. So the example, so that is the CO to CO8 in the solution state. These metal carbonyls, the solution state, there is the no CO bridge bonds. And this another example Mn2CO10 and the OS3CO12 and ruthenium Ru3CO12. So these are the examples without CO bridges. So the structure of CO2, CO8 in solution state, here there is the one cobalt, this is another cobalt metal, the formation of the bond between these two metals. And here each cobalt metal bonded to 4 ligands, there is the terminal ligands, and here also 4 terminal ligands. So there is the no CO bridges in this carbonyl compounds. And the Mn2CO10, here also the two metals and the manganese, each one is bonded to 5 CO ligands in the terminal, and they are directly bonded to each metal. They are the terminal CO ligands. There is the no CO bridges. And another polynuclear metal carbonyls with CO bridges. Example, that is the CO2 CO8 in solid state. In a liquid state or solution state, there is the no CO bridges, but here there is the solid state, there are the CO bridges. And Fe2CO9, Fe3CO12, CO4CO12. So these are carbonyls with CO bridges. The example, structure of CO2, CO8 in solid state. Here the cobalt is bonded, there are the 3 CO ligands in the terminal manner, and these 2 CO ligands, they are the bridged. So the ligand bridging between two metal atoms. So this is also bridging between the two metal atoms. Here the CO ligand can bond to metal by this terminal as the terminal ligands or the bridged ligands. Okay. Next one, the Fe2CO9. Here also the two Fe are bonded to, that is the 3, each one is the 3 terminal CO ligands, and the remaining 3 CO ligands here as a bridged ligands. So these are the polynuclear metal carbonyls with CO bridges. So thank you. Thank you very much.